Dear students, now I am going to start Unit 8 Thermoregulation in Animals. Today I am going to discuss effects of temperature on animals. Thermoregulation in animals. What is thermoregulation? Thermoregulation can be defined as the ability to maintain constant body temperature irrespective to the changes outside environment. So, whatever the changes in the outside temperature or the environmental temperature, the body temperature will be constant. So, for example, if you go to the polar region, outside is the freezing temperature, but your body temperature will be maintained 37 degrees centigrade. Similar with that of you will find in the case of polar bear. It's a mammal, so it's living in the Arctic region, but its body temperature will be maintained 37 degrees centigrade. This is called thermoregulation. How this thermoregulation achieved or else operated, that is going to study in this unit. Temperature variations on land are much more severe than in the water. So, whatever the temperature the changes that affect more in the on the terrestrial animals rather in the aquatic animals. So, whatever the temperature, you will find the minimum temperature that is on this earth, it is observed in Siberia, in the Arctic region. It is minus 70 degrees centigrade. In that temperature also you will find animals like Arctic squirrels and desert fox, and the maximum temperature that is in the Iran desert, that is about 84 degrees centigrade. There also you will find animals. So, the majority of the animals are found in narrow range only within the even though the wide range of temperature you will find in the earth. So, they usually in the narrow range of temperature, that is between 10 degree to 30 degree or 40 degree, in this ranges you will find the maximum animals living in this narrow range of temperature. So, how temperature affects the animals? So, it is explained in the law of Q10. It is also called temperature coefficient. Temperature changes affect all physiological activities of animals. So, rate of metabolic process fluctuate according to the rise and fall in the atmospheric temperature. Association between atmospheric temperature and biochemical process or metabolic reactions or metabolism is stated in law of Q10, that is proposed by the Van 't Hoff proposed this law of Q10 that explains the relation or association between the atmospheric temperature with that of the bodily physiological processes. So, according to law of Q10, for every 10 degree rise in the atmospheric temperature, the rate of biochemical reaction or metabolic reaction it becomes double or 2 times. Every 10 degree centigrade, if the metabolic rate, if it is 1 in a 10 degree centigrade, in 20 degree centigrade it will become double, that means it will be 2. Then it will be in 30 degree centigrade, it will be 4, like that you can see. So, this is what you can see, the law of Q10. So, it is KT plus 10 means divided by, this is the constant, you can see it keep on rising. You will find every 10 degree the rate of reactions or the metabolic activity becomes double. So, KT here the rate of biochemical reaction at the temperature T. The reaction velocity constant at the temperature T, it is the KT plus 10, the rate of reaction at you can see the 10 degree increase in the temperature. So, in chemical reactions, values of Q10 found to be quite constant. So, it is but in enzyme catalyzed reaction, the law is applicable only to certain level, that is at a limited temperature. So, it is for some reaction you will find Q10, you will find it is equal to 3, the constant will be, it is usually it is will be 2, or sometimes it will be 1. So in the case of metabolic reaction, you will find up to certain temperature at about 40 degree, it goes with this, follows the Q10. But after that, you can see the enzyme cannot sustain the temperature beyond 40 degree. There is, you can see the enzyme reaction comes down. So you will find the metabolic activities are regulated by enzymes. Enzyme activity is the highest at narrow range of temperature between 10 to 40 degrees centigrade. Increase in temperature beyond this limit may, you can see the decrease the enzymatic reaction, you can see. So because of the in thermal denaturation of enzymes. So this is how exactly the temperature relationship with respect to the biochemical reactions in the body of the animals. So how the temperature is affecting the reproduction. So the maturation of gonads, gametogenesis, viability of the gametes, all these depends on specific temperature. Temperature determines the breeding season of most of the organisms. So you will find temperature also affect the sex ratio. In certain animals, the environmental temperature determines the sex ratio of the species. For example, rat fleas, the males outnumber females when the mean temperature remains 21 to 25 degrees centigrade. It reverses in cooler days. So here also you can see in the case of testuda, or else you can see it is turtles and tortoise, you can see. So at the lower temperature, the more females. At to 29 degrees centigrade, the sex ratio, the 50-50, the males and females 50-50, and above you will find at 34, then females outnumber the males. So this is how temperature affecting the sex ratio of the animals. That will be reversed in the case of crocodiles. How temperature affecting the embryonic development, ontogenic development. Temperature influences development of both homeotherms and poikilotherm animals. So development of eggs, larvae are more rapid in warmer temperature. So for example, here this is the chironomus larva or else midge larva. It takes 26 days in 20 degree centigrade for the development, for the completion of the metamorphosis, and it takes 94 days in 10 degree centigrade. That's how the temperature affect the developmental processes. And also you can see temperature and morphology. Mammals attain a greater body size when they are in colder region than in the warmer region. So that is called the Bargmann's rule. But it will be reversed in the poikilotherms. They are smaller in a cooler temperature when compared to the warmer temperature. And also the body parts, snout, tail, legs. So for example, they are comparatively shorter in cooler parts, that is called Allen's rules. So the ear, in the case of rabbits, you will find in the colder parts the smaller ear when compared to the size in the warmer parts larger. Similarly, the ear in the case of fox, those are living in the colder and will living in the warmer. So this is how it is the temperature affect the morphology of the animals. Temperature affect the coloration. The size and coloration of animals are influenced by the temperature. In warmer, humid climate, many animals and insects, birds and mammals, they have darker pigmentation than the species found in the cool and dry climates. This is called Geiger rule. So here you will find this is the walking stick insect. You have studied stick insect. At 15 degree centigrade, they are black in color, and at 25 degree they will be brown in color. And also it affect the temperature affect the animal behavior. So temperature influences the migration. You have studied. Temperature influences the behavioral pattern of animals. Cold-blooded animals through thermotaxis or orientation towards the heat through thermoreceptors. Through thermoreceptors, the snake can find its the prey animals. So at a cooler temperature, you will find how the birds huddle. So these are the behavior affected by the temperature of the environment. Temperature also affect the animal distribution. You will find the temperature affects on the breeding in the geographical distribution, breeding and of the animals, and also geographical distribution of the animals. Yeah, and also the survival, feeding, all these are the biological activity that is depending on the temperature of the environment. So the distribution of amphibians and reptiles is limited to the relatively warmer thermal climates. So you will find this is the global distribution of the density of the the amphibians. They are in the major, they are concentrated in the warmer parts of, that means tropical regions of the world where warmer climate. So this is they are very less in the cold region. So this is how temperature affecting the distribution of the animals, animal distribution. So the how exactly the heat transfer in animals. So there is a heat transfer, that is the physics of heat transfer, that is you will find radiation, conduction, convection, evaporation. You have studied. Radiation means the electromagnetic waves, the transfer of energy without heating the intervening air. So that is what we, the body heat we absorb, that is the sun, most important source of radiant energy for most of the animals, especially the poikilotherms. The conduction, direct transfer of heat from the object. For example, this animal is on the rock, so that this is the heat transfer directly in the contact, you can see, that's conduction. Convection, transmission of heat by movement of a medium. So it is the you can see the from the animal the heat will be you can see that is through the convection during breathing and all, it is released to the air, to the water, likewise you can see to the blood. So this is called convection. Evaporation, that is causing the cooling process. So you can see the heat get evaporated when there is a from the body, when there is a cooler environment. So these are how the the physics of heat transfer with respect to the animal. So the animals are classified depending on the presence and absence of thermoregulation. So if the thermoregulation is or temperature regulation, thermoregulation is absent, then animals are called ectotherms or poikilotherms. Body temperature changes according to the temperature change in the environment. Examples are fishes, amphibia and invertebrates. Their metabolic rate and other activities are controlled by the environmental temperature. Ectotherms, that means they become more active when the temperature is high in the atmosphere or else in the environment, and they become lethargic, inactive when the temperature is low. So poikilotherms have a low metabolic rate and high thermal conductance between the body and the environment. They absorb heat quickly from the environment. So they have low metabolic rate when there is a cooler atmosphere. So the animals living in the cooler region are smaller in size as compared to the in the warmer region, and to avoid to reduce the heat loss from the body surface, because they have high conductance, you will find. So these poikilotherms hibernate in winter and estivate in the summer. You will find the amphibians. So these amphibians you won't find during the extreme temperature during summer or else cold season. So in the this is what you can see, the frogs you will find in the during the rainy season. Rest of the season they will be hibernate. So this is the where you can see the thermoregulation is absent. They are called ectotherms. Their body temperature regulation depends on the you can see the it is controlled by outside the controlling, you can see, that is what you can see, not inbuilt controlling system. So then homeotherms or endotherms or inner heat, body temperature is regulated and maintained at a constant level irrespective of the environmental changes. So the mammals and aves evolved with well developed thermoregulatory mechanism. So you are going to study. So you will find the polar bears. Even though in a freezing cold the temperature is in the -10 outside temperature, but the body temperature in the polar bear, it will be maintained 37 degrees centigrade. So homeotherms have a high metabolic rate and low thermal conductance. So they cannot absorb easily the temperature from outside. So they maintain constant body temperature. The high level of aerobic energy production and efficient cardiovascular system can rapidly provide oxygen to all the tissues. So that is how the mechanism operating in the case of the homeotherms, where you can see the well developed thermoregulatory system. Likewise, you have digestive, respiratory and other systems. Similarly, thermoregulatory system is present in these animals, that is homeotherms. They are mammals and birds. So what are the heterotherms? That the constant temperature will be maintained only to certain extent, not fully. They are in between poikilotherms and homeotherms. Heterotherms are in between homeotherms and poikilotherms. Examples are the reptiles and lower mammals and some birds. They are in between ectotherms and endotherms, as they regulate their body temperature by ectothermy, sometimes by endothermy, and environmental temperature determines the mode of their body temperature regulation. For example, hummingbird, bats, some insects and bees are heterotherms. To reduce the energy expenditure during the period of inactivity, small homeotherms, they become heterotherms and show their daily torpor. Torpor means the state of decreased physiological activity in an animal, usually by reduce the body temperature and metabolic rate. So for example, during night time they are inactive and slow the activity of the body, thereby you can see the metabolic rate will be reduced. And when there is a outside temperature will be, and during the daytime the temperature will be optimum. So that's why their highest activity they show during daytime. During night time, low temperature induces reduced physiological activity. This is called daily torpor. So this is what you can see the how exactly in the human. So you can see the during respiration the convection occurs. Then when you expose your body the heat radiation from the sun, then you can see the convection through the body surface from the blood, the heat loss you will find. Then you can see the evaporation that takes place during sweating. So this is how exactly the heat transfer that occurs in your body. This is about the temperature, effect of temperature on animals. How the thermoregulation occurs, I am going to discuss in my next class.